Hello, everyone, and welcome to Database Security Office Hours for July 2019. Our topic this month is Oracle Database Authentication, and in particular, strong authentication, which we differentiate as authentication by anything other than password, pretty much. Security and identity are linked very closely together. A good portion of what we do with database security involves just ensuring that users only see the data that they're allowed to see. And in order to determine what a user is allowed to see, we have to know who that user is. So that process all begins with the user's authentication and identification of the user. Joining us this month, we have Judd Williford, and Judd is with a partner consulting company called Hub City Media. One thing that is a little unique about Hub City Media is that they blend identity management expertise with database security. And they've done really extensive work on many projects with database authentication, including things like enterprise user security, the new 18C feature, centrally managed users, and multi-factor authentication. Hub City is really one of our go-to partners for database authentication, and we're very fortunate to have Judd share his expertise with us today. Just a reminder that we do record these calls, and that the recording for this session and past AskTOM sessions are available on the AskTOM website. Once you go to that website, which is just bit.ly/AskTOMDBSec, click All Sessions to view previous month's recordings. It does take me a day or two to get the recording up after the session is complete, so you should be able to see it on the site sometime Monday or Tuesday. Okay. Office hours are intended to give you a direct line into the database security product development team. We start each office hour session with some announcements, then move on to a presentation on the technical topic, today database authentication, and we finish up with an open line for any questions you may have. Please go ahead and enter questions into chat in this meeting at any time, and we'll get to those during the Q&A segment during the latter part of the office hours. For announcements, we only have a couple this month. The big one is that Autonomous Database Dedicated is now available. Dedicated Autonomous Database allocates your own private exadata in the public cloud. It's the highest level of isolation we're able to deliver so that your workloads are completely isolated from all others. With that isolation comes some flexibility that doesn't exist in standard Autonomous Database, including more capability to customize your operational policies, some different options around transparent data encryption, the ability to use native network encryption instead of just transport layer security, and the ability to use Oracle Database Vault. Also, just a brief reminder that OpenWorld is rushing down upon us. It's September 16th to 19th this year, and believe it or not, that's just a couple of months away. This is going to be a big year for Oracle Database Security at OpenWorld. We've got 11 sessions being delivered by the product management team. We'll also be presenting several mini theater sessions on the demo grounds floor, and our hands-on lab this year will focus on Oracle Data Safe. We really hope to see you there. There's a few new support notes that I'd like to make sure you're aware of. The first is a note on transparent data encryption and key vault integration. This is note 2535751.1. This was something that support created proactively when we first released the new version of Key Vault. And the idea was to track issues as they came up and give you a central place to find those issues and any fixes that we identified for them. I'm happy to say quality for the new Key Vault version is very high, and after several months of being in the field, there is only one issue in that note, and that deals with a challenge around auto login for Key Vault, and there is already a patch for that issue. So there's not much in there for now, but if you are going to be deploying Key Vault, you might want to take a look at this note. Next note deals with installing the Audit Vault agent on AIX. Because of the way Java works on AIX, there is a challenge with TLS configuration. This note identifies that challenge and also gives you the workarounds that you can install your Audit Vault agents on AIX. Next one we want to talk with is a kind of a new way to tell whether transparent data encryption is encrypting your table space's data files or not. And we're using this with a new feature in the DB Verify utility that will tell you that your data file is encrypted. So it's just one more way that you can validate that when you encrypt the table space, that the data files for that table space are truly encrypted. The last one is a note that deals with changing the sys password. And this is perhaps a not necessarily intuitive fact that the password for sys has to be maintained outside of the database because we log in as sys to start and stop the database. So that means that you could potentially be logging as sys when there's no database available. And that means that you can't change the sys password unless there happens to be a password file there. That's not as clear as it could be from the documentation. This new note just kind of clarifies that and gives a little bit of background on why you have to have a password file in order to change the sys password. And that's really it for support notes. Let's go ahead and shift over to today's technical session. And I'm very happy to introduce, again, Judd Williford with Hub City Media. And Judd is going to take us through authentication in the Oracle database. Judd, I'm going to go ahead and stop sharing and turn it over to you.
Okay, great.
And we can see your screen now.
Good deal. And can you hear me as well?
Loud and clear.
Great. All right. Yes. So I'm here to talk about database authentication. Oracle provides a really extensive set of options for this, and we found some really interesting things that we can do with those options. So that's a lot of what I've got to cover today. As Russ said, my name's Judd Williford, and I work for Hub City Media. I've been working with Hub City for 5 years. I've established their database security practice. We do product implementations for all the database security products and work with customers to make sure those fit into their environments and deal with their security and compliance issues. And then we are able to leverage in a very convenient way the ongoing skills that the Hub City team has with respect to identity and access management and directory services for LDAP. So that's really who I am. I actually did work at FedEx for a little over 30 years, and I see Jim Blazek's on the call. So howdy to Jim there, and good to see you on the call. So this is kind of a breakdown of what I'm talking about today. We'll talk through at a somewhat rapid pace what the Oracle Database Authentication architectures are. I'm going to drill down a bit on the directory-assisted authentication options because there are two now with 18C. The centrally managed users gives you a second choice with respect to managing authentication in the database. Then I've got a pretty rudimentary matrix that I put together to compare the authentication alternatives. And it's not meant to be any kind of a definitive source, but I think it'll at least give you an idea when you're faced with an authentication choice, how to make that choice. And it'll factor in your environment as well, because that's a key aspect of that decision. And then finally, I'm going to talk about achieving multi-factor authentication, which is a hot topic today. And there are some ways to do it in the Oracle database that are pretty interesting. Okay, just to kick off the topic, thinking about what database authentication is doing, obviously there's that key step of establishing that the user is legitimate. If you think about it, that's complicated somewhat by the fact that during the process, there are credentials that are going to have to travel back and forth. So it becomes very important to protect those credentials from theft during that. So you don't have, a form of identity theft there. So for a local connection, if you're just connecting at the server itself, that's a fairly simple process. But when anything is remote, you've got to deal with trust between the client and the server, and then network exposure when the credentials are traveling. I don't want to overemphasize the role of the client in this whole process. It's one of the things that bites customers more than anything else. So if you think about it, the database and the client have to negotiate the authentication mechanism that's going to be used. And again, there's a choice. There's several sub-choices as well. And then they have to also agree on how they're going to secure the credentials as they traverse across the network. So that means clients have to have some consistency, some level of currency, so that they are able to achieve all the things you want them to achieve when they're talking to your database. The client platforms are really notoriously difficult to manage, though, and that's primarily because in a large organization, it's difficult to control who does what on their client. And some clients are very, very old and haven't been touched in a while. Organizations are stepping up to this with endpoint management software that will help them with that. And some are able to do a great job with that, but you just have to keep that in mind. Another point has to do with actually the role that the client has in being able to support the various algorithms that are going to be used for authentication. So Oracle supports a number of APIs. There are, there's the Oracle Full Client. There's a couple of JDBC options. So those APIs have to be available, and the APIs themselves have different compatibilities with respect to authentication methods. So for example, to configure JDBC with Kerberos requires a lot of configuration at the client to get that to work. And then you layer on top of that, on the client, you've got various tools. You may have Toad, you may have SQL Developer, and each of those tools have different compatibilities with respect to these authentication methods. Just really quickly, this is a picture that represents, in this case, it's the Oracle Full Client. This is from the Oracle Net Services manual, but it just shows you, some of the pieces that have to be in place. You can see along the bottom there, the set of adapters that deal with strong authentication. So we'll be talking about Kerberos, SSL, and Radius. So what I'm going to do now is step through these four authentication algorithms, again, pretty quickly, but just talk about some of the considerations and the architectures that are behind them. First, for passwords, of course, that's the default. There's really no client-side configuration needed. There is, however, a verifier that's essentially a hashed version of the password. The client has to be able to produce a verifier that the database will accept. So there's some negotiation there on what that verifier is. In addition to that, the client and the database have to negotiate SALT for the more recent verifiers. There's SALT included with the password. It's like an added set of characters that the database provides to the client. It gets hashed together. It affects the results of the hash. So the database has some awareness of the fact that SALT was used, and it helps with the verification process. So the client converts the user-entered password to the verifier and sends it to the database. The database receives the copy of the verifier from the client. It compares it with the copy of the verifier it has on hand. If it's a match, then the database authenticates. Talking about these verifiers, and many of you, I'm sure, have seen a lot of the evolution of this, but originally with 10G, I'm only going to go back that far, you had the MD5 algorithm, and that one was fairly easy to hack. Now, what do we talk about what do we mean when we talk about hacking a verifier? Obviously, the verifier is not reversible. So in order to hack it, that's where we get these brute force attacks, which are essentially generating all possible sets of passwords, up to a point, and then hashing them, and then matching that hash against the hash of a password that you are trying to crack. With MD5, that's a lot easier to do, primarily because MD5 generates a hash that has fewer characters than some of the more recent algorithms use. So And also MD5 doesn't use any salt, or it actually does, but the salt's understood to be something that's well known. With 11G, Oracle stepped up its game and introduced the salted SHA-1 verifier. It includes salt, and also the SHA-1 algorithm generates a good bit many more characters than MD5 did. So if that improved the security, there were weaknesses with SHA-1 as well, though. You know, as computing power keeps increasing, these things become more and more of a factor. So with 12C, Oracle introduced the SHA-512 algorithm. These little codes next to the side are actually the names of the protocols that the client and database have to support. That includes not just the encryption, the hashing algorithm, but also the salting method, all the aspects of the process whereby the verifier is produced. So just some notes on this. Again, clients have to be able to handle the protocol in order to produce the enhanced verifier. And so you have to make sure your client's able to generate, you know, these more up-to-date verifiers. That means you have to upgrade clients in many cases. The verifiers and password and just regular local password, those verifiers are actually stored on the database. So that represents some risk for any verifier, the fact that it's stored on a database locally. And if you want to see it, actually, you can look in the spare for column of the DBA users table. To add to that risk, as databases have been migrated over time from 10G to 11G to 12, those old verifiers get retained unless you take special actions, which are well documented in the database security guide, to remove them. So, but you can't remove those you can't remove those verifiers until you can be sure that all of your clients can handle the newer verifiers. Okay, that's all I'm saying about password authentication right now. Moving on to Kerberos. Kerberos is pretty well known. I think probably most people have come across it because it is the authentication algorithm for a lot of the single sign-on functionality that's built into Active Directory and your Windows desktop. It involves a three-way trust model where you have the client, the server, in this case the database, and then a third party, which is called the key distribution center. The key distribution center takes the role of authenticating and then verifying that each party is who they say they are. Some notes about Kerberos. The client platform has to be able to authenticate to the KDC. That's the first step before the client can try to authenticate with the database. The client's database API has to be configured for Kerberos because the conversation between the client and the database is different. They're no longer exchanging password verifiers. They're now exchanging these tickets. And then there is some configuration at the database level as well. And that's because now the database has to talk to the KDC in order to verify the credentials of the client. So this is a real basic picture showing this, just a little graphic to help you register in your mind. So the client, oh, I'm sorry, I went too fast. The client authenticates and receives the ticket from the KDC. This is automatic with Windows. When you log into a Windows server, if you're on an Active Directory domain, this is the process that happens. You get a ticket and it's maintained on your Windows desktop. For other platforms, you can use the OK init utility, which is built into the full client to actually perform the same kind of function. Okay, the next step is that the client presents the ticket to the database in conjunction with a login request. And that's all under the scenes, right? From your standpoint, you're just typing in connect, and the ticket gets passed automatically because of the configuration. The database receives the ticket and then negotiates it with the key distribution center to make sure that it's authentic. Oh, one thing I forgot to point out is just the fact that ticket isn't a permanent thing. It actually has an aging factor to it, so it has to be regenerated from time to time. All right, moving on to Radius. Radius authentication has been around for a long time as well. Radius is essentially an open source service that's well-defined. It's got lots of customizable options with respect to how authentication occurs. What essentially happens when you're authenticating to an Oracle database with Radius is the database takes the authentication information that comes from the client and just passes it over to the Radius server. And it's essentially a trust basis there between the database and the Radius server that the credentials I'm sending you, you're going to be able to do the work to authenticate, and whatever you say about it, I'm going to take your word for it. The Radius server, though, is able to negotiate with other authentication services. There are lots of APIs provided for various services. And so once the Radius server does get a successful authentication from one of those services, then it responds back to the database, and the database understands from the Radius server it can approve the connection. There's a challenge response option with Radius. We'll actually see that. I'm going to give a demo here in a minute, and you'll see what that looks like. It's basically a way to provide additional information. So this is one of the ways that multi-factor authentication is accomplished with Radius. So that's what I had to say about that. Again, there are some notes that I put in here about some of the impacts of Radius. One thing that sometimes troubles auditors is the fact that Radius credentials are encrypted, but they are reversible. So if somebody got hold of them and was able in some form or fashion to decrypt them, it would be easy for them to get hold of those credentials. But we try to take measures to make sure that encryption is effective and prevent that from happening. Many products do incorporate a Radius server. The Oracle documentation talks about RSA for one, and there's another one too. I can't remember what it is, but RSA has the secure ID tokens and provides, along with that, a Radius service that you can hook your Oracle database up to. If challenge response is used, there's a client configuration aspect that can be hard to manage, and that's the fact that there's a some Java classes that you have to provide on the client. The nice thing is those are customizable, so if you need to write some kind of unique way to capture the information that you want to pass back to Radius, it's possible to do that. However, the downside is you have to make sure that you can push that Java configuration out to every client. And there's also some database level configuration required too, so that the database has credentials and is able to talk securely to the Radius server. I didn't do any automation here. I just grabbed these two pictures out of the database security guide. You can see the two forms of authentication. Just simple Radius authentication is a once and back interaction where the information with the credentials is passed from the Oracle server to the Radius server. Additional operations can be performed by the Radius server to sort out the pieces that it receives there and send them to the authentication server, which then gives the go, no go message back to the Radius server, passes it on back to the database. On the right-hand side, you can see the challenge response flow, which has that initial set of authentications followed by additional information that can be collected by the challenge response. That's at bullet sub in there. And then that information gets passed back and additional authentication can be performed. Okay, I'm just saying a little bit about SSL authentication. I don't know if folks have tried this before. It does have some complications associated with it because of the fact that you have to manage certificates on the client and the database in order to perform the authentication. Essentially, you generate tickets, you store those tickets in Oracle wallets, and then you have to configure both the client and the database to understand that I'm looking for these certificates and authenticating by means of PKI to ensure that that's working. A nice thing that I've seen done before is a lot of like government agencies and others that have really high security requirements, they actually can store their certificates on the smart card. And so the only way you can authenticate to the database is by sticking that smart card in your client and the client reads the certificate off the smart card and uses that to do SSL authentication. Okay, so my next topic is directory-assisted authentication. And again, we've got two flavors for this now. Originally, we had just Enterprise User Security. We refer to it as EUS. It's been around, I think it goes back to 9i anyway. Anyway, it's been around a long time. And then now we also have centrally managed users. Centrally managed users is available with Database 18c and up. Both of these use an LDAP directory. Enterprise User Security has a few options. Centrally managed users has only one, and that's Active Directory. We'll talk about the pluses and minuses a little bit, but centrally managed users is it's much simpler. So that's one of the pluses for it. So both, though, are able to map directory users. So these are users in LDAP to accounts in the database, and then even to provision their sessions with roles that are managed by group membership. So a user in a particular group can log into a database with a particular account and receive a particular role based on the LDAP information. A directory-assisted authentication can use multiple of the options we already talked about. You can use password-based authentication. You can use Kerberos. You can use certificates. The only thing you can't use is Radius. So Radius is not compatible with directory-assisted authentication. Now, one thing to consider about the password authentication option is with directory-assisted, you've got to find that verifier somewhere. It's no longer in the database. The user is now in LDAP. So that means you have to find a way to capture the verifier, an Oracle functioning verifier, and place that in the directory. So that's one of the tricks that both of these tools have to pull off, and they're able to do that. The big deal for both of these tools, and I think this is why we see a lot of interest in these products, is that it gets you very close to DBA-less user provisioning and authorization. So if you think about the amount of work a DBA has to do to create users, to change passwords, to reset accounts, to grant the users the appropriate roles based on job changes, all those kinds of things create a lot of extra work for DBAs who would really much rather be doing things like tuning databases and designing schemas. So these are really the big hitters, the big hitter benefits of directory-assisted authentication. For the CMU architecture, I don't have any animation, but I did pull this diagram, which is, again, right out of the Database Security Guide. It does a really good job of representing the parts of CMU. So you can see the users on the left are able to authenticate to the database with either password, Kerberos, or PKI. The database interacts with Microsoft Active Directory. It's Active Directory only, to gain both the authentication data, which is essentially additional information about the user's identity, as well as that password verifier. Up in the upper right, you see the little card that represents the plugin that you place on the Active Directory controllers. This is called a data capture. The password capture DLL. So it's a piece of code. It's configured into the workflow when AD passwords change, it gets fired, and as a result, it generates the hash using the actual password that got entered at password change time, and then it stores that hash in the user's record on Active Directory. Once the database retrieves the verifier and also group membership, that's another thing that has to happen, is the group memberships are needed. Then the Oracle database is able to refer to information inside its own catalog to determine what users can log into what accounts and what database roles they get. Again, that's based on their Active Directory group memberships in the main. Okay, now to compare that with EUS, you can see right off the bat here, EUS has an additional component. And that's a plus and a minus. On the plus side, it gives you a place to maintain this information instead of storing it on the database, as CMU does. On the minus, it's an additional architectural component, so it's a potential point of failure, and you have to take that into account when you're configuring EUS. So to show how this all happens, first of all, you authenticate to the Oracle database, again, with password Kerberos or PKI. The database passes along a search. This is essentially what CMU is doing too. I just didn't have the animation for this. So I didn't talk about that before though. The actual way the user logs into the database, it's not providing a database account name. In fact, that's how the database knows it needs to authenticate against the directory. It has this user name and it says, I don't have a local account for this guy. I need to call out to OUD to see if OUD can authenticate the user. So what that ID is can be any number of things. It can be the SAM account name on the Active Directory side, or it could be a UID. So there are some options there. It's configurable, but essentially that's what the Oracle does. It takes that identifier and sends it to the directory. And I've got OUD here. I forgot to speak about that. But OID is another directory product that Oracle provides that supports EUS. Either one can do it. Okay, OUD passes that ID search along. It's actually able to package that up in a certain way so that it makes it more secure, so that the interaction with Active Directory is more secure. And then Active Directory responds to the search request with information, including how that ID relates to the actual identity of the user as it's maintained on the database. The verifier gets passed back. Again, you can see there's the DLL there for the password capture, and group membership, just as we saw on the CMU side. Okay, OUD takes that information and massages it. Again, as I said before, with CMU, all the information about what groups and what users get mapped to what accounts and what roles, that's maintained in the database. For for EUS, that's managed in the directory. So OUD does some processing on that, and what it actually returns to the database is just the verifier and the account that the user can authenticate to on the database, and the actual role mapping. So what roles the user will receive when they log in. So as a result of that, the user is able to get a session on the database under that account that was designated and receive the grants that were designated by their group memberships. So it's really, in terms of the processing, it's very similar, EUS and CMU. The only difference is where the mapping information is stored and the fact that you've got that additional component. Plus, I guess there is also some benefits from EUS. It's got a little bit more flexibility in terms of what the sources are for your LDAP data. It's not just AD. Okay, and one thing, and many of you are familiar with this, one thing you get with an EUS implementation, if you're not already using it, is the ability to use the Oracle directory to manage net service name resolution, which is, again, a huge boon for organizations who, today have to manage tsnames.aura files on their clients. By moving to net service name resolution, the clients can actually resolve database locations through the information that's in the directory. Talking a little bit about the differences, EUS does require Oracle Directory Services instance or multiple instances because you typically want to ensure high availability. The choices are OID and OUD. The Oracle Directory can hold user groups information in itself, or it can proxy to Active Directory or other LDAP. The mappings are maintained centrally in the Oracle Directory, and EUS provides both a graphical tool, and it's embedded in Enterprise Manager, as well as command line tools for managing those mappings in the directory. For CMU, you don't have to have that Oracle Directory service. The downside is it works only with Active Directory. Of course, also it only works for 18C and up. But and the other thing is the mappings are maintained in each database instance with DDL. Now, you could see that as an up or a down. The up is it's easy to get at it with DDL. You don't have to have a special API or LDAP experience to do that. But the downside is, in order to both maintain and report on the information, you have to hit each database. All right. So now moving on to my, again, pretty rudimentary comparison of authentication methods. I talk about each one, give it sort of a complexity ranking, and then talk about what some of the best fit considerations are. So just running through this list, we have password first, obviously very low complexity. It is the simplest, and that's good in many scenarios, but there is more work to secure it. And also there's more work at the database level with respect to ensuring password policies are enhanced and managing problems like password resets. For Kerberos, complexity is medium high. There is a lot of work to do because every client and every database has to be configured for Kerberos. That configuration can be pretty tricky if you're doing it for the first time. Where this really fits well, though, is when enterprises have already deployed Kerberos across the enterprise. So if you think about it, I mean, it may be, you have just, you're a Windows shop, so everything's Windows, you've automatically got Kerberos there. If you have other platforms, a lot of times people use different, privileged access products like Centrify. Centrify deploys Kerberos. There are others that do that kind of thing to actually roll out Kerberos across the enterprise in a very consistent way. Those environments work good with Kerberos, but it's still a good bit of work at the database level and the client level to make sure that your database authentication works with Kerberos. For Radius, I took it down a notch from Kerberos. It's not quite as complex to implement as Kerberos. Radius is a great answer when flexibility is needed, and also for multi-factor authentication. PKI is very high. It's the highest in terms of complexity just because of all the activities that have to be engaged in for each client, for each database, for each user to make sure that, that this piece works. So I would only recommend this in some environment where high trust is needed. I have seen, I've seen auditors come in and say, okay, this particular set of connections from, maybe from a particular application server or something like that needs to have PKI implemented. So something like that makes sense, I think. Then I have EUS and CMU here. Both get medium to low complexity ranking. A lot of this is probably debatable. I kind of thought, and from what I see in terms of people who are going with EUS, the things that are driving them to EUS at this point is, for example, if they're large organizations and they see taking on CMU as creating a lot of additional work. If you think about it, that work is multiplied by the number of databases that you have. I mean, to some extent, that's true for EUS as well, but it's a lower number. EUS also gives you a little bit of an easier path to separation of duties because the interfaces to manage the mappings in the directory are different. They have different credentials. For CMU, you've got essentially to do separation of duties, you'd have to grant limited DBA privileges to some sort of security admins, and then deny or closely monitor or implement database vault rules to keep the DBAs from doing that. And then the other thing comparing EUS and CMU is just the database version level support. But that's pretty well understood. We've already talked about that. Okay, so moving into my my last topic, which is multi-factor authentication. This is something that we're seeing a lot of increased demand for across the board, and we know it's driven. It's driven by PCI for one thing. The latest PCI DSS 3.2 specified a requirement for multi-factor authentication for privileged accounts. We're seeing customers going to MFA for every account just because they figure that's where it's headed anyway. GDPR, actually, I don't know if you saw, but just yesterday in the paper, there was a notice about Great Britain having put out 2 of the largest GDPR fines ever done. One was 200 million to British Airways, and the other was 100 million to Marriott. So GDPR is definitely getting teeth, and I think that's going to drive the demand for making sure that multi-factor is implemented where it needs to be. NIST is another, that's the U.S. government standard that many people are moving to, or just at least pointing to as a resource to tell us how to do our jobs, even if it's not strictly a compliance regimen. I talked in the last half of this slide about the various factors that are used for multi-factor authentication. These are familiar to everyone, but I thought I'd just kind of put them here to remind you. There are one-time password sources. The most familiar is probably the RSA Secure ID token generating key, fob, and but there are a number of others that are available now on the phone. We'll actually be looking at one in our demo that it's the Oracle Authentication the Oracle Access Manager one-time password generator. Some proxy cards have a PIN associated with them. I've worked with customers who use it's a smart card, not a proxy card, but a smart card that that has a chip in it. There's a PIN associated with it. You stick that in your computer, the computer reads it and picks up the PIN that you enter. Just another form of authentication. The push authentication is, I don't know, I'm sure you've seen this before. This is like Google Authenticator, where essentially the radius server pings the authentication service. The authentication service sends a signal to the phone. The person who receives it, responds appropriately and sends that back to the authentication service. All of that happens out of band, so there's no need to interact with the database client in any way to form that second factor. That's kind of a cool thing about that. Okay, and then there's the biometrics, like fingerprints. Okay, so MFA on the Oracle database is been around for a lot of years, actually. I can't remember. It'd be interesting to go back and see how far back it goes, but the documentation about how to configure Radius against RSA has been in the manual for at least a decade. I can vouch for that. Longer than that, I'm sure. It is documented in the Database Security Guide. There are several options for capturing the second factor. The challenge response, which is that client Java class I talked about before, can be written to perform the capturing of the second factor. We've also done it for customers by concatenating the second factor with the password. Obviously, that carries a little bit of requirement that the password never contain the delimiting character for the concatenation process, which sometimes can be a bit of a challenge. But and then the other thing is the out of band, which I mentioned before. So that's the push notification where the authentication pings your phone. Okay, so I'm going to show you just real quick a little video that shows our product. We actually have built a Radius server similar to what RSA would have done. We've hardened it and put in some automatic configuration scripts so that it can automatically adjust to your environment. It'll pick up on, for the first factor, it'll do IDCS, it'll do Active Directory, and it'll do another, just general open LDAP type of directory as the first factor. And then for second factor, it's able to handle the Oracle Access Manager Authenticator. That's the phone app I was talking about. We also work with a vendor called Twilio that has the app Authy. It does one-time password or push. And then we're working with some other second factor providers too. They have APIs for this kind of thing. So we'll be in the demo using the Oracle Identity Cloud Service. So this is a cloud service that gives you essentially a directory in the cloud, and as well as some identity management tools on top of that. And then we're going to be using the Oracle Access Manager Authenticator as well. So what I'm going to next is a video. And this video, I'm going to shut down the sound on it. You can also watch this on our website if you want to. And I'm also going to jump ahead because there's a lead in that takes way too long. Okay, so what you're going to be presented with here on the, let me make sure I'm ready. Yes. On the left that's your phone screen. That's the Oracle Mobile Authenticator app. You see it's got a 6-digit PIN that it's generating. The life of the PIN is 30 seconds. You'll see that through the course of the demo ticking off. In the upper right is a terminal window running SQL+, and you'll see the actual Radius authentication happen there. Down in the bottom right is the kind of behind the scenes view of what's going on. So we'll see the interactions that happen between the architectural components. So the first thing that's happening here is the SQL+ login, and that's a Radius login. You'll notice there's no user ID or password. That's all handled, in this case, through the challenge response interface. So that pop-up occurred there. That's the challenge response interface capturing the first factor and the username. Okay, that gets passed over to the database, receives that information that was keyed into in this case, keyed into the API. It passes it directly over to the Radius server in the middle. The Radius server interacts with IDCS in our case to provide the username and password. The IDCS server actually authenticates the password at this point. Again, remember that password's not hashed, it's actually encrypted. And then it sends back the confirmation of authentication or denial, as well as information about the user ID. That user ID that got passed back is so the multi-factor databases, multi-factor Radius server is able to negotiate with the MFA. Okay, the window now that you see is the second factor being captured through the challenge response interface. So that's coming back at the bottom from the user to the database. The database passes that along to the Radius server. And now the Radius server is interacting with the MFA service to confirm that the factor that was provided, that one-time password, is legitimate. And then the Radius server communicates back to the database the fact that this user is good. And up in the upper right, you see the connection happen. All right, just a couple of other things to talk about. One is I wanted to sort of show you visually what this second factor concatenation method looks like. You'll notice the pound sign in the middle there. Basically, we just give you the ability to define a delimiter. But again, one major concern there is that none of your passwords that are managed in, in this case, IDCS, can use that pound sign as one of the characters in the password. The nice thing about second factor concatenation is you don't have to worry about that Java class. The Java class on the client platform can be, a pain to have to manage. Okay, and then just talking about the out of band, you don't need a Java class for that. You don't need a delimiter. So, if your company is already looking at that sort of push authentication method, that's a great one to adapt, with Radius and into the database authentication for multi-factor. There's a link there to that video that you just saw, so if you want to go back and find out more about it. Okay, one additional way we have done MFA is we found a way to do it with the US, and we're actually doing this today with an international bank, and we've got other banks that are interested in doing this as well. This is accomplished, and we'll actually in the next slide we'll look at that EUS architecture picture that we showed before. It's possible with the Oracle directory to implement a plugin. The plugin is essentially a piece of code that intercepts those searches that come from the database and then go across to your LDAP source and can perform different actions. So we essentially are using that capability to step in and do the second factor authentication. Right now, it only works with password authentication. You can't use this plugin if you're doing Kerberos. The other, sort of seemingly odd thing about this is that since there's no challenge response capability as there was with with radius. So we have to provide the second factor unless the second factor is delivered through the push method that we talked about. It has to be delivered in a concatenated form. And the other thing is, it has to be concatenated with the login ID. It can't be concatenated with the password because the password's getting hashed. You know, in an EUS password-based authentication, that password gets hashed by the client before it ever gets sent to the database. So to protect it from being hashed in with a password and no longer usable, of course, the password's no longer usable either, but we have to concatenate it with the login ID. That's a little awkward, but actually, you know, our first customer accepted it. They thought it was, you know, acceptable because, you know, they just were very excited about this mechanism for accomplishing MFA. The other thing, though, is they're also doing push authentication. Push authentication works really well in this kind of a scenario. Another nice thing about this particular method is the fact that EUS in the directory is already managing a good bit of information about the databases, about the users. So this plugin can leverage that information and make decisions selectively about what databases or what users to require MFA for. So if you think about it, that's pretty cool. We haven't implemented it yet, but we figured we could also map into this whole management structure what authentication platforms are acceptable for, you know, on a user basis or whatever. So there's a lot of opportunity here, we think, for this. This is a little bit of the architecture. This is exactly the same picture that I showed before for EUS. The additional component is that plugin. It sits in between the passing of the ID search from the database through to Active Directory. It essentially strips out that second factor, or in the case of push, it goes ahead and interacts with the authentication service to obtain the authentication either through the second factor or the push. Something else you can see here that's a little bit different about this model. It's, you know, it seems a little backward, and you know, it's not going to work for everybody. But the second factor has to be authenticated first, because the authentication for the first factor, which again is the hashed password, that has to traverse through the Active Directory or whatever your user information source is, go through retrieving the verifier hash and get back here before it can happen. So it seems a little backward, the fact that the second factor gets authenticated first, but it works. And as I said, we are seeing some demand for it. Okay, I'm wrapping up here. This is just a list of things I didn't talk about, and many of these things you may have some familiarity with already. Impact on database links, that's kind of an interesting one. And both EUS and CMU are able to take care of that pretty neatly. That's something that's interesting to talk about. Also, Database Vault has a command rule for connect. So that's a way to control authentication if you've got Database Vault deployed on a database. But I want to move to my conclusions, which are, first of all, that Oracle provides, you know, the broadest set of options with respect to database authentication by far. We've worked with other databases for customers trying to get, you know, consistent authentication methods in place, generally using a directory, and it's more difficult for those other databases. Oracle gives us lots of options. When selecting an authentication option, you've got to consider the client platform. You've got to look at it from an enterprise level. What's the work that you're creating for yourself when you're doing this? Every enterprise is different, so I can't answer that question for you. The third item is just auditors who are asking you to get your databases on MFA. They can be appeased. I've talked about a couple of ways to do it. Again, there's other ways documented in the Oracle Security Database Security Guide, so be sure to look there. All right, so that's it for me.
All right, thanks, Jim. I'm going to go ahead and, or Judd, I'm going to go ahead and take it back over. All right. Again, everybody, Judd's doing this out of the goodness of his heart. Thanks, Judd, for taking your time today. We had Judd up at 4 a.m. this morning, his time, delivering the first of the AskTOM sessions. So thank you very much. Just a reminder, Autonomous Database Dedicated, now available, and OpenWorld coming up very quickly. And with that, before we move into the question and answer period, just a quick reminder, office hours next month is Thursday, the 8th of August, and our topic tentatively is going to be Oracle Data Safe. So we hope to see you there for that one. We're going to go ahead and move into the Q&A section. Only one question came in on chat during the presentation, and that was a pretty common one. Whenever we're talking about something, is PE bar, and apologies, I don't know the name behind that, asked if all this cool stuff requires additional licensing. And I gave an answer in chat, but as Judd was going through his presentation, I realized that I did make one mistake in my answer. So from a database standpoint, using Kerberos or Radius or Enterprise User Security or PKI certificates for authentication, that does not require any additional license. Way back when, it used to require advanced security, but we got rid of that license requirement in 9i Release 2, okay? What does require an additional license is if you are using Enterprise User Security. Judd showed a picture where he had OUD, Oracle Unified Directory, in there. That could also be Oracle Internet Directory. That directory has to be licensed. But from a database standpoint, there is no requirement for additional licensing. Anything else that Judd talked about, Kerberos, Certificate, Radius, none of that requires additional licensing. Same thing for CMU. Any other questions? Nothing else came in on chat, but you've got probably one of the best security DBAs that I know on the phone with us in Judd. So if you've got a question, great time to ask it. Well, Judd, I think that must mean you did a really good job on the presentation. It's probably the most complete treatment I've seen of the topic. I had one for you as you were going through. You talked about Radius and the fact that we're passing credentials in encrypted format rather than hashed format. Is it possible to do Radius over TLS?
Yes. Yes, I think it is. Now let's see. Between the client and the database, I'm not exactly sure how that would work, but you can definitely do that between the database and the Radius server.
Okay.
I think we actually do that.
And I know between the client and the database, we can also do TLS. So that might be a way to mitigate that concern if someone brings it up is, yes, we are passing credentials in reversible format. There's really no way around that because we have to be able to use those credentials.
Right.
But we are doing that over a channel, or we can do that over a channel that is encrypted using the same type of encryption that you would use to pass credentials over a web or any other channel. So that should take care of objections, I would expect.
Yeah.
All right. Let's see. What do we have in chat? There was one question that came in chat, and that was from Paul Coe asking, and what Paul asked, and I hope I understood the question correctly, but he asked a follow-up, so I may not have, is for EUS AD authentication, what are the Oracle OUD software components required? And I answered more technically than from a license standpoint. What I said was you can either use Unified Directory, in which case you can either do synchronization or LDAP proxy, with LDAP proxy being the most common, or you can use Internet Directory. And if you're using Internet Directory, again, you can either use synchronization, where you copy AD into Internet Directory, or you can use its version of LDAP proxy, which is called server chaining. Either one works for CUS. With CMU, which if you look in the archives, we talked about that on AskTOM a few months ago. We removed the need for the additional directory by shifting all the metadata into the Oracle database. And then Paul asked, do you mean Directory Services Plus product? From a license standpoint, yes, that's what you license is Directory Service Plus, and that includes both Unified Directory and Internet Directory. That was—
Yeah, hi, Russ.
Go ahead.
I got another question privately from one of the listeners, and they said they were asking about whether EUS required advanced security. And of course, the answer to that is no. EUS is delivered with every Enterprise Edition database, and CMU is as well, but of course it has to be 18C or up.
Correct. If you go back to Oracle 8i, which is when we first introduced EUS, we initially had that as part of advanced security, and we removed that requirement in 9i Release 2. 9.2, we shifted it from being an extra cost option to just part of the database. EUS was very, very common, especially during 2004 period and on, as people were doing a lot of work around Sarbanes-Oxley. And just there was no need to have it be a separate license because it was so commonly used back then. Just so everyone on the phone knows, in addition to removing the license requirement for EUS, we also removed the license requirement for network encryption. So at the same time that we made EUS part of just the standard database, we also made network encryption something that you could use without having an additional license. Guys, a few more minutes before we close it off. If there's any questions, feel free to either unmute and ask them or enter them into chat. And if not, you're welcome to go ahead and drop off, and we will see you hopefully next month for AskTOM's Database Security Office Hours.